Audiobook Academy Biography presents Werner Heisenberg. Quantum physicist and philosopher Werner Heisenberg, born Werner Karl Heisenberg, December 5, 1901, February 1, 1976, was one of the most influential scientists of the 20th century. He was awarded the Nobel Prize for Physics in 1932 for his discovery. He published his most famous and foundational philosophical work, The Uncertainty Principle, in 1927. He also made significant contributions to the theories of turbulent flow hydrodynamics, the atomic nucleus, ferromagnetism, cosmic rays, and subatomic particles, and he played a key role in the 1957 planning of the first West German nuclear reactor in Karlsruhe, along with a research reactor in Munich. When it comes to World War II atomic research, there is much debate. Education. Heisenberg's father, August Heisenberg, was a professor at the University of Würzburg and a specialist of ancient and contemporary Greek philology and literature. Mother Anna Weckelein was the daughter of Maximilian Gymnasium rector Anna Weckelein. In 1910, August Heisenberg joined the faculty of the University of Munich as a professor of Greek philology. The following year, Werner was accepted into the Maximilian's Gymnasium and quickly made an impression on his lecturers with his prodigious mathematical ability. In 1920, Heisenberg enrolled at the University of Munich, where he studied atomic spectroscopy under Arnold Sommerfeld, a proponent of the quantum model of physics. Since 1913, Danish scientist Niels Bohr has advocated for the notion that certain attributes of the atomic scale are discrete or quantized, rather than continuous. Heisenberg completed his doctoral dissertation on hydrodynamics in 1923. Even though his dissertation defense was less than stellar, the anomalous Zeeman phenomenon, which causes atomic spectral lines to break into many components when subjected to the influence of a magnetic field, revealed Heisenberg's true abilities. In order to account for this occurrence, Heisenberg came up with a model that introduced half-integer quantum numbers, a concept that is at odds with Bohr's theory as currently understood. But in 1922, while he was still formally Sommerfeld's pupil, Heisenberg joined Max Born's class at the University of Göttingen and met Niels Bohr. In 1924, Heisenberg received his habilitation, a German academic credential that allowed him to teach at a university. Quantum mechanics. At the University of Copenhagen's Institute for Theoretical Physics, Heisenberg studied electron spectra as an anharmonic oscillator in 1925 after spending time there with Niels Bohr, a one-dimensional vibrating system. Quantum theoretical reinterpretation of kinematic and mechanical relations was key to his 1925 paper, Über quantentheoretische Umdeutung kinematischer und mechanischer Beziehungen, Quantum Theoretical Reinterpretation of Kinematic and Mechanical Relations. When Born and his new helper Pascual Jordan figured out how to use matrix algebra to represent Heisenberg's non-commutative multiplication formalism, they submitted their findings to a journal under the title Zur Quantenmechanik, English title, On Quantum Mechanics. Zur Quantenmechanik 2, On Quantum Mechanics 2, informally known as the three-man paper, was finished in November by Born, Heisenberg, and Jordan. It is regarded as the founding document of a new quantum mechanics. Uncertainty principle. Bracket notation and the wave equation were two further formulations of quantum mechanics produced in the early 1920s. Dirac invented the bracket notation, and Schrödinger developed the wave equation, where the Austrian physicist was then working. As soon as Schrödinger showed that the various formulations were mathematically similar, it was unknown what physical value this equivalence had. When Heisenberg returned to Niels Bohr's Copenhagen Institute in 1927, their discussions resulted in Heisenberg's seminal work, Über den Entschullichen Inhalt der Quantentheoretischen Kinematik und Mechanik, on the perceptual content of quantum theoretical kinematics and mechanics. The principle of uncertainty, or indeterminacy, was laid out in this study. Particle momentum, p, and position, x, according to Heisenberg, could not be precisely measured at the same time in quantum mechanics. To put it another way, a relationship exists between the indeterminacies, in the measurement of these variables, such that pxh/4. In other words, if the uncertainty in one variable decreases toward zero, then the uncertainty in the other must increase in the opposite direction. This relationship exists between any pair of canonically conjugate variables such as energy and time. Heisenberg came to a philosophically significant conclusion: total causal determinism is impossible since it necessitates the exact knowledge of both position and momentum at the outset. The use of probabilistic formulations in atomic theory was not due to a lack of knowledge, but rather because of the inherent indeterminacy of the variables involved. The Copenhagen interpretation of quantum theory was based on this premise, which was strongly defended by Bohr at his Copenhagen institution. Schrödinger and Einstein, two of the greatest physicists of the 20th century, were among those who considered the renunciation of deterministic causation as insufficient. Nobel Prize. Professor Heisenberg was appointed in Leipzig in 1927. For his part, he started on a research project with others like Dirac, Jordan, and Wolfgang Pauli with the goal of developing a quantum field theory that combined quantum mechanics with relativity theory to better understand particle field interactions. The discovery of the neutron led to Heisenberg's work on the atomic nucleus, where he developed a model of proton and neutron interaction in an early description of the strong force. It wasn't until November 1933 that the 1932 recipient of the Nobel Prize in Physics was revealed, along with the rest of the year's Nobel Prize honorees. For the 1932 Physics Prize, Heisenberg was awarded, while Schrödinger and Dirac shared the 1933 prize. Heisenberg and the National Socialist German Workers' Party. The National Socialist German Workers' Party, NSDAP, came to power in 1933 at the same time that Heisenberg was given a Nobel Prize. Nazi Party. Non-Aryans and the politically untrustworthy were omitted from the civil service by the Nazis, which meant the firing or resignation of many scientists and academics, including Einstein and Schrödinger and some of Heisenberg's classmates and colleagues in Leipzig. Afraid that the Nazi government or its most extreme expressions would last for long, Heisenberg's answer was mostly a series of modest interventions within the bureaucracy. Ideological criticisms were also leveled at Heisenberg. German or Aryan physics, as opposed to Jewish mathematical techniques, such as relativity and quantum theory, was championed by a Nazi-affiliated group of scientists. One of the movement's leaders, Johannes Stark, made advantage of his Nazi party ties to exert control over science funding and hiring. Seeing Heisenberg as his ultimate successor, Sommerfeld invited Heisenberg to join him at the University of Munich in 1937. Heisenberg was nicknamed White Jew and Ossietzky by Stark in an article published in the official SS publication. He was a German journalist and pacifist who was imprisoned in 1931 for treason for reporting on Germany's secret rearmament operations, was granted amnesty in 1932, and then rearrested and imprisoned by the Nazis in 1933. Heinrich Himmler's family had a close relationship with Heisenberg's mother's, so he asked the SS chief to help him get a position at the University of Munich. In the wake of an investigation, Himmler decreed a compromise. Heisenberg would not succeed Sommerfeld in Munich, but he would be spared further personal attacks and, basically, given another key position in the future. In the meantime, Stark and the Aryan physicists were losing their sway in the Nazi state's bureaucratic jungle for a variety of reasons. Despite the political upheaval, Heisenberg never seemed to seriously consider leaving Germany, despite several job offers in the United States and elsewhere. He seemed to be guided by a strong feeling of professional obligation and a national allegiance that transcended the specific politics of the government in which he found himself. After meeting Elizabeth Schumacher, the daughter of a professor of economics during a concert, in 1937, Heisenberg married her in 1937. The next year, the couple welcomed their first set of twins, the first of 7 children. In contrast to the cascade theory favored mostly by British and American physicists, Heisenberg's main attention in the late 1930s was on high-energy cosmic rays, for which he presented a theory of explosion showers in which numerous particles were generated in a single operation. Heisenberg thought cosmic ray events could support his theory that the domain of quantum mechanics has a minimal length. Second World War. The atomic nucleus became a hot topic with the discovery of nuclear fission. Heisenberg was recruited by the Army Weapons Bureau to work on the topic of nuclear energy after the German invasion of Poland in 1939. To begin with, Heisenberg commuted between Leipzig and the Kaiser Wilhelm Institute, KWI, for physics in Berlin, where he eventually became the institute's director after 1942. Obviously, in light of the Nazi setting, this role has generated a lot of debate. Of course, Heisenberg's research group was unable to produce a reactor or an atomic bomb during their time. Heisenberg has been portrayed as either incompetent or intentionally delaying or sabotaging the project in various accounts. In hindsight, it is evident that several key blunders were made during the research. There is little doubt that Germany's involvement in the development of nuclear weapons was less enthusiastic than that of the United States Manhattan Project. A larger influence was played by events outside Heisenberg's direct control. Germany's endeavor was bureaucratically fragmented and cut off from international collaboration. In contrast to the united Anglo-American effort, the Allied bombardment of Germany's transportation system resulted in significant disruptions and a severe shortage of critical commodities. As a result, nuclear bomb research was either prioritized or deprioritized based on the broader strategic perspective. Minister Albert Speer concluded that reactor development should continue, but that no weapon would be built in time to be used in the war after meeting with Axis scientists. As evidence, the Manhattan Project began in the United States in 1942 and failed to build an atomic bomb before Germany's surrender despite its huge effort. Heisenberg's lectures in Denmark and the Netherlands during World War II sparked controversy. Because these excursions outside of Germany had to be approved by German authorities, they were seen by colleagues in the occupied nations as a sign of Nazi officials' support for Heisenberg and vice versa. His talk with Bohr on the subject of nuclear weapons research during a trip to Copenhagen in September 1941, which he later said was based on a misinterpretation, was the most well-known example. It's unclear exactly what was said during the conversation. Hackingen and Haigerloch, then a Prussian outpost, now a part of Baden-Württemberg, were chosen as the locations for the KWI for physics evacuation in January 1945. Heisenberg rode his bicycle from there to his family's vacation home in Bavaria in the final days of the war. An American military intelligence squad discovered him there, and he was later detained in England with several other German physicists. After hearing about the atomic bombing of Hiroshima, Japan, Heisenberg seemed to lack a basic understanding of bomb design concepts, such as the estimated critical mass, but within a few days, he had solved many of these difficulties. Heisenberg and Bohr were friends. After World War II, Heinrich Heisenberg was released in January 1946 and returned to his post as head of the Max Planck Institute for Physics in Göttingen as soon as possible following his release. Post-war, Heisenberg took on a range of administrative and public relations jobs for German science in West Germany, which was a break from his previously non-political approach. Heisenberg served as the first president of the German Research Council, a consortium of the Max Planck Society and the various West German academies of science that aim to promote German science in the international arena and influence federal science funding through the newly elected Chancellor Konrad Adenauer, in 1949. When it came to cultural and educational problems, this new group clashed with the previous Emergency Association for German Science, which had been founded and re-established. The German Research Association was formed in 1951 when the Research Council and the Emergency Association combined. When Germany joined the European Council for Nuclear Research in 1952, Heisenberg was a key player, CERN. When the Third Humboldt Foundation was established in 1953, Heisenberg was its first president. The Humboldt Foundation was a government-funded organization that offered research fellowships to international academics. Heisenberg was a member of the Göttingen 18 in 1957, a group of nuclear scientists who produced a manifesto condemning the government's plan to equip the Army with American-built nuclear weapons following the disclosure that the government was considering doing so. The scattering matrix technique, first suggested in 1942, and the idea of a minimal universal length were significant features of Heisenberg's search for a comprehensive quantum field theory in the post-war period. The term world formula was coined by the press to describe his 1958 proposal for a unified field theory, which he saw as an approach to the multiplication of particles based on symmetry. However, the physics community's support for the quark hypothesis in the 1960s was limited. It wasn't until the Max Planck Institute for Physics relocated to Munich in 1958 that Heisenberg was able to secure an academic position in his hometown of Munich. In 1970, Heisenberg stepped down as director of the institute he founded. Thank you for listening in Audiobook Academy. Don't forget to subscribe and smash that like button for more content like this. See you in next video.